Hi, hello everyone. Welcome to my channel SR University for Future. Last class I have discussed about how buck converter we are going to design and along with that buck converter operation and functioning waveforms last class we have seen. Now coming to today we are going to see how boost converter, inductor and capacitor designing will be done at different duty cycle conditions and what are the things are there in the derivation of the duty cycle like peak to peak current ripple, peak to peak voltage ripple, everything we are going to see in this lecture. Now, first foremost thing when we are going to design any power electronic converter, we have to follow certain assumption. What are those assumptions? We will see now first. First foremost assumptions are first assumption. What is the first assumption? What is first assumption here? When we are going to design any power electronic converter, it should be in ideal condition. It should be in ideal condition. It should be in ideal condition. Ideal condition, it is nothing but switching loss, switching loss, that is switching conduction loss is negligible. Negligible. And next, second one is whatever the voltage drop that is there across the utilized diode that is equal to 0. So next, third one, what we have to see, whatever the internal resistance are there, that is RC and RL, some internal resistances. What are the internal resistance are there for the boost converter passive elements that are equal to 0. So that is the first condition. In that sub conditions are these three. Now coming to the second condition, whatever the source power that is there, that should be must and equal to the load power. That is second condition, particular condition. Here, the inductor value, utilized inductor value must and should be higher, must and should be higher value, must and should be higher value, must and should be higher value. Then whatever the load currents are there, it will be uniform nature. That is the condition for the higher amount of inductor utilization. Now fourth one, coming to the fourth one, higher amount of capacitor. Capacitor value should be higher. Capacitor value should be high. Then what we can say that the load voltage, whatever the load voltage will be there, load voltage we can maintain constant. Load voltage we can maintain constant. That is the condition. Now next the condition is switching frequency. F switching that is equal to constant. Switching frequency is constant and load is purely resistive. Load is purely resistive. Load is purely resistive. And next assumption is what we have to say that converter, it has to be operated in it has to be operated in continuous conduction mode. Then only we can derive the inductor values and other things. Continuous conduction continuous conduction mode. Then only it is a possibility of derivation of inductor. Now these are the assumptions we have to follow for the derivation of the inductor and as well as capacitors. Now we'll start the derivation. Inductor derivation, whatever the selected utilized inductor it is there, boost converter, inductor boost DC to DC circuit design. So first foremost thing is, as we know that when the switch is on here, volt second balance we have to apply. Volt second balance of inductor we have to apply. Then what is the volt second balance equation? Voltage across the inductor under T on condition plus voltage across the inductor under T off condition must and should be equal to 0. Then only we have to derive the other things. Now what is T on? First we have to know what is the duty cycle condition. What is duty cycle? It is nothing but T on, that is how we are going to derive duty cycle. T on is equal to D times of Ts. Then duty will be represented as duty D is equal to T on by Ts. That is the duty cycle representation. Now, as per our discussion, inductor voltage under T on condition, inductor voltage under T off condition, we will derive now. What is the inductor current under switch on condition? That is VL is equal to VDC into T on plus what is the switch off condition under switch, that is minus Vs plus VL plus V naught, that is VDC minus V naught under T off condition is equal to 0. Here we have to indicate that what is VDC minus V naught, we have to indicate now. Now coming to that, here what is T on, we have to represent that T on, it is nothing but D times of Ts plus VDC minus V naught D time 1 minus D times of Ts. So those things we can represent it and we can calculate the value of the duty cycle. D is equal to 1 minus what we can calculate here. Basically, what is the formula? V naught by Vs. Previous class we discussed 1 by 1 minus D. Now we need to derive V naught D value. V naught minus D times of V naught minus D times of V naught, that is equal to Vs. Now what is required? V naught minus Vs is divided by V naught, that is called duty. Here V naught will get cancelled, then Vs by V naught. This is the duty cycle derivation for the boost converter circuit. Now we will calculate the peak to peak, peak to peak inductor ripple, peak to peak inductor ripple along with the inductor value. Delta IL we will see. Now, as we know that VL is equal to VDC and VL, how can we write it? VL is equal to L into DIL by dt. Let us take it as a VDC constant. Now, in this condition, as I previously discussed, that delta IL is equal to I maxima minus I minima. Now, what we can write it here? L into delta IL is divided by T on, that is equal to VDC. From this, how can we write it that VDC, that is, let us take it as a, let us discuss about T on value. That is T on is equal to L into delta IL is divided by VDC. These things we have to remember. Similarly, we will derive what is the voltage under T off condition. Under T off condition, what is the formula? VL is equal to VDC minus V naught. Here, what is VL? L into delta IL. Then that is the case here, discharging the condition. L into delta IL is divided by T off. Here, take it as a minus common. Then V naught minus VDC. Minus minus will get cancelled. Then that is the case. T of, how can we write it here? T of is equal to L into delta IL is divided by V naught minus VDC. That is the condition we have to derive. This is the T on as well as T off. From these two derivations, what we are going to do? We are going to calculate the total time T is equal to T on plus T off, that is equal to what is T on? L into delta IL is divided by VDC. Next, what is T off? L into delta IL is divided by V naught minus VDC. Next, when we observe that what is the time? 1 by frequency. Then 1 by frequency T on plus T off, that is equal to here in this term as well as in this term, both the terms, what is the common thing is there? That is L into delta IL is the common. Then 1 by VD plus 1 by V naught minus VDC. That is the final thing. Then after that 1 by F, that is equal to, make it as a common, then VD minus V naught minus VDC. That is here we have to take it as a VDC. Then what is the top one will come? V naught minus VDC plus VDC will come. Now finally what we can write here? Minus VDC plus VDC will get cancelled. Then that is the case. What is the thing will come here? Finally, V naught is divided by VDC. Let us take it as a V naught minus VDC. So this is the formula. Now coming to this, how can we write it here? Let us talk about 1 by F, that is equal to V naught is divided by VDC, and again make it as a V naught common, then 1 by, what we can write it here? Let us take it as a, what are the thing we are going to take it here? Then we are going to take it as a VDC will be V naught will be get cancelled, then 1 minus VDC minus by V naught. Then that is the case. What we can write it here? 1 by VDC by V naught, that is equal to, what we can write it here? Here we forgot L into delta IL. We have to write it in everywhere. L into delta IL. Again here also L into delta IL. Here V naught into delta into IL into L. Finally, how can we write it here? L into delta IL is divided by VDC into, what we can write it here? VDC into duty cycle. This is the final formula. Then how can we write the final formula? That 1 by F, that is equal to L into delta IL, that is divided by D times of VDC. Here how can we write it? That from this equation we can write the first inductor formula, that D into VDC is divided by, D into VDC divided by, what we can write it here? D into VDC is divided by, then L means F into delta L. This is the one form of the inductor formula. From this equation, peak to peak ripple, how can we calculate peak to peak ripple? That is equal to delta IL is equal to D into VDC is divided by, D into VDC is divided by, how can we write it? That F into L. This is the peak to peak current ripple and inductor value of the boost DC to DC converter. Boost DC to DC converter circuit. So this is the inductor formula and peak to peak ripple. So coming to that, we have to indicate that what is the ripple of the value. Ripple here, when we are going to derive the ripple, we have to remember some fundamental formulas. What are those formulas? We will see now. Now, when we are going to derive, let us talk about voltage ripple. Voltage ripple, when we are going to derive voltage ripple, we have to know some fundamental formulas. Current flowing through the across the current is, conductor is I is equal to Q by C. From this, sorry, Q by T. I is equal to Q by T, dQ by dt. That is called current flowing basic fundamental formula. So from the waveforms, we know that delta Q is equal to T on, that is switch on time, and I naught value. Let us take it as here. What is the switch on? As we know that T on is equal to T times of switching time, total switching time. Then how can we write it? Delta Q, that is equal to, what is T on? D into Ts into I naught. So this is the delta Q. As we know that delta V, that is equal to delta. Otherwise we can write it like that. See, that is how can we write it here? Delta Q, it is nothing but, what is the thing here we written? Delta Q, it is nothing but, if you write it in terms of frequency, delta Q is equal to D into I naught by frequency. So after that, what is the formula for capacitor? Capacitor C is equal to delta Q by delta V. From these derivation delta Q, what is delta Q here? C is equal to D into I naught is divided by F into delta V. That is what are the things I written here? I included delta Q, that is D into I naught is divided by F into CV. This is the capacitor formula for the boost DC to DC converter circuit. From this, how can we write it that ripple voltage ripple of the capacitor delta V, that is equal to D into I naught is divided by, what we can write it here, F into C. Here purely resistive load, then that is the case, how can we write it here? I naught is equal to V naught by R. Then that is the case, finally delta V is equal to D into V naught by R into F into C. So these are the derivations we have to remember for the calculation of the numericals. So now what we can do, we will see some competitive exam problems and how we are going to apply these formulas for those numericals we will see now. Now for the first problem we'll see. Here, first problem is, let us take it as a numerical 1, that is P1, problem 1 we will take now. See problem 1 we will see. What is problem 1 here? We'll see now one by one. A DC to DC, what is telling here in the problem? A DC to DC boost converter. A DC to DC boost converter. A DC to DC boost converter as mentioned in below figure. As mentioned in below as mentioned in below figure is used to boost 360 volts to 400 volts at at a power at a power of 4 kilowatts. Here all the devices are in here all the devices are in ideal condition. Here all the devices are in ideal condition. And assume that assume that the converter is operating. Assume that the converter is assume that the converter is operating at continuous conduction state. Conduction continuous conduction state. Then evaluate the then evaluate the what is asking, then evaluate the first one duty ratio, second one first one duty ratio, second one IRMS. So these two are we have to solve now. Now step by step we will go through that, and what are the data he given, everything we will observe now. Now first foremost thing is answer we are going to calculate now. we are going to calculate as a answer. Now first answer, coming to the answer, first we have to mention the given data. What is given data? We will see now. Here he given the converter circuit also. Then that is the case. We have to draw the converter circuit. Here what he given we will see now. Here he given the converter circuit, that is inductor as well as one switch, and as after that there is a, this is plus minus what he given here, 360 volts input that he given in the numerical. And then what is the thing here next he given, that is inductor. What is that? 10 millihenry he gave the inductor value, that is L. And after that there is a diode element, it is indicated over here, that is D plus minus. And after that what is the capacitor value he mentioned here? The capacitor value, that is 1 millifarad, he mentioned that value. And after that he mentioned the load, that is what is the load voltage he mentioned, that is 400 volts load voltage he mentioned. This is the circuit he given in the numerical. Now coming to the given data, what is the source voltage here? Source voltage. What is the source voltage? VDC, that is equal to 360 volts. What is the load voltage? Load voltage V naught, that is equal to V naught is equal to 400 volts. Now this is the what is the circuit here? Boost converter circuit. From the circuit, we have to observe that from the circuit, what is the voltage gain formula? Basically, V naught by VDC, that is equal to 1 by 1 minus D. Now, what is asking? What V naught already he gave, that is 400. And what is VDC he gave? 360. And what is he's asking? Duty cycle he's asking 1 by 1 minus D. Now, before going to that, what we have to do? We will see 400. Sorry, here we will write 400 minus 400 times of D, that is equal to 360. Now, what I will write it here, 400 minus 360, that is equal to 400 times of D. Now, what is D value? That is equal to, what is here? What he written here, 400 minus 360, that is equal to 40 is divided by 400. 40 will get cancelled. Then 0.1, that is the duty cycle. So from this, A answer is clear. Now coming to the B answer, when we are going to derive the B answer, we have to be clear about it that steady state condition. What is steady state condition? Steady state condition. Steady state condition. What is the condition? We have to observe that steady state condition, whatever the source power it is there, that should be equal to the load power. Then what we have to write it here? What is the source power? We will have to write it here. That is equal to Vs into Is. That is equal to V naught into I naught. So what is the source voltage? Already he gave in the numerical. That is 360. What is the source current? He is not mentioned there. What is the source voltage? That is 400. What is the source current? Load current? That is, he haven't mentioned that. That is why he directly given the problem. So I not he is not given. Then what is the load power he given? That is 4 kilowatts. Then let us take it as a 4 kilowatts. That is the P out. So here directly P out he given instead of P naught he given P out. That is why indicated here 4,000. Now what is IS? IS, that is equal to 360 is divided by 400. Now 360 is divided by 400. What is that? If you calculate 11.1 amps approximately, it will come. Now he is asking RMS source current. IRMS, that is equal to 11.1 square root of D. What is D? 11.1 into square root of D, that is equal to, what is that? D 0.1. Then finally, what is the answer? We will get it there. Approximately 3.5 amperes. So we have to remember, this is the overall problem for the boost converter circuit. This is the problem which is given in competitive examination. Now we will see one more problem, that is how we are going to solve. For those problem we will see now. This is somewhat little tricky. You have to be very careful when we are going to solve the next problem. Now let us take it as a second problem, second numerical. We will see the problem two. What is problem two? He given that, let us see. A step up chopper is used. A step up chopper is used to deliver. A step up chopper is used to deliver load voltage to deliver load voltage of 400 volts from a 200 volts DC source. From a 200 volts DC source. If blocking blocking period of the thyristor, if blocking period of the thyristor, if the blocking period of the thyristor is 80 microsecond, then then determine the then determine the thyristor on time, then determine the thyristor on time duration. Now we have to calculate T that we have to derive now. Now we'll see the problematic how he solved for step by step. We will see now. Now let us take it as a answer. Foremost thing we have to think about it when problem is given. We have to read the problem twice and thrice so that you can understand what is the way we are going to obtain the answer for that. So first delivery load voltage. It means here step up chopper. First step up chopper means this is we have to confirm that this is the boost converter. This is boost converter circuit. So boost converter circuit, what is the load voltage he given? That is V naught, that is equal to 400 volts. So that is one concept. Now coming to that, what he is saying that these 400 volts, it is coming from the source utilization, that is 200 volts. It means two times it is increasing. So 200 volts, it is going to 400 volts. Here, thyristor, whatever the thyristor, let us draw a small graph. Here he indicated that what is T on time, what is T of time, what is T on time, he is asking. Let us take it as this is T in terms of seconds. This is T on time duration, this is T of time duration. So these two are the T on and T of time duration. This is thyristor switching pulsar, that is VG we indicate. Now he given already this T on value. What is the T on thyristor blocking? Sorry, he given the T off period. That is what is T off? That is equal to T off is equal to 80 microseconds. He given already. Now first when we are going to derive time duration, we have to calculate. He given only output voltage, input voltage, time duration. Then he's asking Tn. Tn we need means then we must and should we have to calculate the duty cycle. Now going to the duty cycle, we know that for the boost DC to DC circuit, for the boost DC to DC circuit, for the boost DC to DC circuit, what is the formula there for that? V naught by Vi, that is equal to 1 by 1 minus D. Here what we have to calculate? D we have to calculate. From this, here what he given already. Before that, we will take it as a duty cycle, right? Then V naught minus D times of V naught, that is equal to Vi. So what we need now? V naught minus Vi, that is divided by V naught, that is equal to D. Now what we are going to do here, duty cycle T is equal to 1 minus Vi by V naught. This is the duty cycle. Now coming to that, what is the input voltage he gave? That is 1 minus 200 is divided by 400. Then two zeros will cancel. 1 2 jar will cancel. Then duty cycle D is equal to 1 by 1 minus 1 by 2. Then if you derive this, if you calculate this, what is the duty cycle? 0.5. So here we have to observe that one clear point, that is